right 1 minute past 4, and my name is Maxime Flamand. I'm a coordinator for research support action called VRA, Vehicle and Road Automation. I work for Ertico ITS Europe, and today we will have a webinar on cooperative automation and basically the activities of the European project iGain. Just a little bit of information about the webinar, the interface. You have on your right side control panel. You can click on this little arrow and then the control panel appears. You can adjust your audio using the audio panel, audio setup. If you have any questions, you can just enter your questions in the question pane, and we will monitor the questions during the whole webinar. And at the end of the webinar, we will come back to the Bastian Crosse and moderate the question and answers. You can also press on full screen, auto hide the control panel, and so that you can look at the slides in a nice way. So all participants will stay muted during the presentation. The participants also can pose these questions via the control panel, and we will come back to these during the question and answer. The slide numbers, if you have a specific questions, please mention the slide number in your question so that we know what you're talking about. There will be also a series of webinar polls that we will do during the course of the 1 hour. A poll is basically an interactive questions from the presenter to the audience. And when a poll is started, you will directly see a screen with the question, and you just have to make your choice as soon as possible. The results will be shown right after the poll is finished. To illustrate the polls, we can perhaps start with one first poll to make sure that everyone understood. So we will start with a simple one. From which region are you from? And you have to answer either from Europe, from USA, Asia Pacific, or others. So, and then we can see from our side how many people have voted. So we are at 87% of votes, and then now so we can close the polls. So we have 90% of people who have voted, and we can show directly to you the polls that are. So we have a 3/4 of the audience that is from Europe, another 18% from US, 4% from Asia Pacific, so it must be really late for them at night, and others 4%. So, okay. So now I come back to my presentation, and I will just give you a little bit of information on what the support action that I mentioned at the beginning. So support action is a project that is 100% funded by the European Commission. It is, and VRA is specifically there to create a collaborative network between the experts and the stakeholders working on the deployment of automated vehicles and its related infrastructure. There are two main pillars on which we are working in VRA support action. One, work on the European network of experts, and we choose to foster this cooperation within the automation working group of the Air Mobility Forum. And then the second pillar is the international pillar, is the collaboration between EU, US, and Japan in the trilateral working group on road vehicle automation. And this group is chaired by the European Commission, the DOT in US, and the Japanese MLIT. In order to give as much information as possible or as much content to these two pillars that I mentioned, we have a series of discussion groups that are here listed. This discussion group look at different deployment needs for vehicle and road automation and feed the discussions within the Air Mobility Forum and the EU, US, Japan ITS collaboration. We try to, as much as possible, promote the research on vehicle and road automation, and this is done with a wiki where you can look and look up all the different activities that we know of around the world. So I mentioned so the wiki, the website also, where we post as much information about the VRA activities. We have a Twitter account where we feed this Twitter account with vehicle automation news, so don't hesitate to sign up to it, and then or to follow it, and the wiki that I mentioned, and then the webinar series that we have today, where we ask different activities around the world to report on their progress. We have a series of beneficiaries and associated partners for this support action, and anyone that wants to join us is very welcome. And the way it is done is that if you want to be actively participating, you have to sign a letter of intent. So VRA is supporting and contributing to many events, and among them I show a few that are in our list for 2015. Next week we will have a workshop on socio-economic impact of road automation and also CityMobile demonstrations. So it's mainly organized by CityMobile 2, followed by a trilateral automation working group meeting. Also a bit later we will have an EU-US symposium on organized by DGRTD, European Commission. Later in July, the TRB AU VSI Automated Vehicle Symposium in Ann Arbor. And I would like to skip the others, but then the next ones that I would like to mention is really the ITS World Congress in Bordeaux, where also we will co-organize the ITF VHA together with our US colleagues. So with this, I would like to give the floor to Bastian Cross. He will talk about cooperative automation activities in the European project iGame. However, I would like to perhaps launch another poll, so to make sure that you're all awake. And so the other poll is actually another simple question, is which sector are you representing? So automotive manufacturer or supplier, public authority, research organization, service provider, or other. So please, yes, so we have about 77% of votes, so then we can close as soon as we are at 80. So 91% of votes, and then what are the statistics? Well, pretty well spread. 19% of automotive industry, 25% of public authorities, 31% of research organizations, 6% of service providers, and others 19%. So with this, I give the floor to Bastian Cross.
Thank you, Maxime.
Yes, thanks. I was hoping that you would. So
thank you, Maxime.
Thank you very much.
Yeah. My name is Bastian Cross from TNO, and I will shortly introduce to you the iGame project. iGame, it's an FP7 project, and it stands for the Interoperable GCDC Automation Experience. And in this case, the GCDC means the Ground Cooperative Driving Challenge. Where did we start? Well, actually, from 2008 until 2011, we developed a challenge based on a DARPA challenge, which was called the Ground Cooperative Driving Challenge. And in this challenge, many teams from the European Union, but also from the US, participated in a challenge, and in the end, 9 teams made it to a final event where cooperative automated vehicles challenged each other on a highway section. And one of the most interesting results of this initiative that there was a close collaboration between many OEMs, suppliers, students from universities. So there was not just one winner, it was one big cooperation event. And that tasted for more. And based on that, we applied for a European project, and the end result is the iGame project. The result of the project is to speed up the real-life implementation of wireless communication, and wireless communication in the context of automated driving. And the interesting thing of this project is that there are two key elements. On the one hand, we developed new technology on environmental perception, actuation, interaction, on wireless communication, the key element of this project, on safety, and on the mixed traffic interaction. And that's the development part. And at the same time, we have a demonstrating element, which results in 2016 in a challenge where we again will invite teams from all over the world to participate in this challenge. And in this challenge, we will ask people to come up with multi-vendor solutions, and we focus on the standardization of the communication technologies that are developed, and on the verification and the validation of the developed technology. And of course, in the end result and the end goal is to enhance public awareness about cooperative automation. The main project objectives are, on the one hand, that we want to come to a unified functional architecture and requirements for interoperable cooperative automated driving. So the key element is that we are focused on multi-vendor solutions, but we want to have a unified architecture. The interaction protocols between the vehicles are key of this project, and also a standardized interaction message set. We want to deliver messages that can be used for future ETSI protocols. And of course, the validation and certification of the tools and events are a key element in obtaining this. So this is about the goals of the project. But if you want to get focus in your project, you have to have key scenarios in which you test and develop the cooperative automated systems. And we chose to have two scenarios. And together with a reference group where people from industry, from research organizations, from suppliers, they gave their input on the scenarios that we chose. There's one on a highway section and another one on an urban scenario. The highway scenario was inspired by the first DC-DC. Here you see two platoons of vehicles, different types of vehicles. There can be either trucks or cars. Different types of vehicles are allowed. The challenge in this scenario is that the platoon on the left side has to merge in between the vehicles on the right side. And you can imagine that a lot of interaction between the vehicles is needed. All vehicles drive in automated mode. That means both in longitudinal and lateral direction. And this all happens at a speed of about 60 kilometers an hour. The second challenge is about a cooperative intersection. And here it's about collaborating between vehicles to make sure that you can enter a piece of road. The vehicle comes from the bottom of this junction and has to find a gap to go to the left. And while doing that, he is in a mixed traffic situation where both non-automated and automated vehicles are driving. And the challenge is to create a gap without coming to a standstill. To give you an idea of what this looks like, we made a reference implementation of 3 vehicles who can do the highway scenario, and I now want to show you a movie. This is a bit challenging, so we will try it once more. Unfortunately, it is not working at this moment. So we will, for those of you who are interested in the movie, we will share it with you, and we will also make it available on our website. To continue with the presentation, the end result, and of course the biggest element of this project, is the final event. The final event will take place in June 2016. The exact weekend will be determined on short notice. The idea is to have a 2-day event with a preparation week in advance, where the teams that participate have their final moment to test their vehicles to make sure that everything is safe and under control. And at the end of the challenge, there will be a 2-day symposium at which all the participants can share their results with a bigger audience. That's the idea of the challenge. And for those of you who are not yet involved, we really welcome you to contribute, to be part of the challenge in any way. It can be either as a member of a team or in any other constellation. You are very welcome. So join us in the GCDC. I now want to give the floor to my colleague.
Before we continue, I think there was one simple question is whether bikes are foreseen in the scenarios, or is there anything that is included, especially you in the Netherlands, I guess, is there bikes also included in the concept?
No, we only have motorized vehicles with at least 4 wheels.
Okay, that's already a start.
Yeah.
Okay.
So if there are no further questions, we would like to continue and go into a bit more depth of the project, so the key element of this project. And I would like to give the floor to Ms. Elham Semzer.
Good afternoon, ladies and gentlemen. I'm Elham Semzer from TNO, the Netherlands, and I would like to give an introduction to some activities within iGame project. But before going into details, I would like to place this poll, which is what kind of automated driving support would you accept as driver? And yeah, there are 4 options, so if you can choose your option, then I will continue with my presentation.
We start. Hide. No. Sorry, we have a small problem. We went a bit too. We pressed on that too fast, so we have to reopen the poll before we can restart it. So we'll come back to the poll as soon as possible. Yeah, I suggest you start already with the next.
Okay, sure. So I will give a short outline of our presentation today. So I, together with my colleague Jaco, will go into some details of the interaction protocols that we have developed for performing the iGame scenarios, and the focus is mainly on one of these scenarios, which is cooperation on highway, because of the lack of enough time, so we couldn't go into both scenarios. And after the interaction protocol, my colleague will continue with the message sets which are needed for implementation of the interaction protocol, their design methodology and message flows, and also the solutions for new message sets. Although Bastian already explained about the scenarios, I would like to show you some pictures and how these scenarios look like. For cooperation on highway, we have 2 platoons driving the highway, and 1 lane we have a closure of the road. So the platoon which is on left lane has to merge within the platoon on right lane. And that should be done through cooperation among both platoons. And then in the second scenario, we have an intersection with a secondary road, a car driving on a secondary road, and it wants to enter a main busy road where normally it cannot get access. But through cooperation with some vehicles, which are shown in yellow, and they give way to the car which is coming from the secondary road. And of course there is a second scenario in iGame which is for demonstration purposes only, and it's about giving way to an emergency vehicle. But we only focus on the first scenario in this presentation. In any case, for executing any of these scenarios, the first element that we need to develop is an interaction protocol. And an interaction protocol can be characterized by a sequence of maneuvers and a set of wireless message. And also the control system of each vehicle should have this capability to implement this interaction protocol. Our methodology to address these scenarios and to implement these scenarios is based on decomposing the scenarios into simpler tasks which we call maneuvers. Let's say for a scenario like lane reduction, we can define or we can decompose it into 3 maneuvers of gap making, merging, and platooning. And then for implementing or for performing any of these maneuvers, we should have some high-level controllers, which are called in our framework agents. Let's say for maneuver of gap making, we need a controller which is in charge of vehicle following, like cooperative adaptive cruise control. We should have a controller which makes enough gap for sake of gap making, and we should have some type of lateral controller. And therefore, for a scenario like lane reduction, which is the focus of iGame, we need several agents, several high-level controllers corresponding to each maneuver. So this is the setup that we need for our control implementation. And therefore, and on top of that, we need the interaction protocol. And for the iGame scenario on highway, there are some practical issues. Let's say if every car wants to merge from the merging platoon into the gap-making platoon at the same time, there would be a huge deceleration at the platoon tail, which is not comfortable and not desired. And also serial merging one vehicle at a time is not time efficient, so that's not also a solution. And there are uncertainties in terms of which car should merge where. So these are the 3 minimum requirements that the proposed protocol should address. And that was the guideline for us to come up with our protocol. Now I go into the different phases of the protocol. So the first phase is called pair up, whereas the cars in platoon B starts to pair up with the car in platoon A. So in a sense, the cars in platoon B, they start to open the gap for a car which is relevant for them. And this is based on the distance. So the forward closest vehicle is taken as the pair. And the idea of these pairs are communicated and they are fixed to the end of scenario. Then in the second phase, the pairing is done from platoon A to platoon B. And this stage is done serially, so one vehicle at a time. So starting from the lead vehicle in platoon A, it starts to find a partner in platoon B. And when the gap is big enough for a safe maneuver, for a safe merging, and then the car in platoon A go into merging status. And then it opens the floor for the car following it to start negotiation and making the gap. And this goes to the end of platoon A. So by the time that the first car reaches the merging region, just right before the construction site, then it has enough gap and it's able to merge in platoon B. And this goes on to the end of platoon. And also for added safety, we envisaged a message which is safe to merge. So each car in platoon B has to send a safe to merge message for cars in platoon A to make sure that the gap is big enough and the maneuver can be done in a safe manner. Now I give the floor to my colleague to continue with the message sets that are involved for execution of this interaction protocol.
So before we go for the next one, we can relaunch this poll that we missed. I'll let Davide relaunch that. And so now it's for you to answer, what kind of automated driving support would you accept as a driver? No, I want to be in control. Some basic support systems would be nice. More advanced cooperative automated driving systems, or fully automated driving. Of course, always this is open to interpretation, but let's see what you are answering. So we have 92% have voted, so I think we can close 95%, and let's see the results is 0% that no, I want to be in control. So some people are convinced here. Some basic support systems would be nice. To 1/4 of the participants. 37% say more advanced cooperative automated driving system, and then 40% say fully automated driving. So very interesting poll, but I think we are talking to the converted. So so let's continue with the second part of that very interesting presentation. You have the floor.
Yes. Okay. Thank you very much. My name is Jacco van der Sluis, and I will talk about the work that we are doing on message sets. So first, let me talk about the approach we are using. We already have some experience from the first GCDC, and what we do is we have some tested implementations, and we can work on those implementations that are already tested and already proven into practice, and we can extend on it and enhance on it, and we can combine those to really support the complex maneuvering needed in our iGame scenarios. And what we do, we take as base the current ETSI standards on cooperative ITS, and we use that as a basis to investigate what is currently available and how can we use that those kind of messages in our interaction protocols. And we are also seeking alignment and collaboration with other projects going on in the EU goals. So from that, we want to extend the current COM and denim message sets currently available, and define new message sets when we need to. So this is all being done at this moment, so it's still work in progress. So it's good to have some feedback from you on the work that we are doing. So when we continue with the design approach for the 3 scenarios that we have defined in iGame, what we do from determining the main stages in each of those scenarios, we determine what kind of message flow is needed in those main stages, and we investigate what kind of information then needs to be exchanged and what are the characteristics of this kind of information, what are the real data fields that need to be transferred during within those messages. And yeah, for sake of time, we only focus on the merging scenario today. So I would just want to keep it at a high level. Don't go into too much detail about this, because we really don't have the time. On the left side, you see some of the main stages that we have identified, and you already saw some of that in the presentation of Elham on the interaction protocols. On the on the left side below you see a little figure that is a platoon A and a platoon B. So platoon A is on the left side of the road and platoon B is on the right side of the road. Those vehicles, you can also see them on the top level of this diagram, represented over here. And when you look at this, you can also see what kind of information has to be transferred from vehicle in lane B to a vehicle in lane A. And we define different pairing stages and also the sequential pairing stage. And for every kind of main stage that we have identified, we have worked out examples of the message flow that is needed. And if we look at the message flow that is needed to support a scenario like the merging scenario, these are the data feeds that needs to be exchanged while executing the scenario. So this is just to give you an idea what are the data types that really are needed to be communicated between those vehicles. And if you look at solutions that we can use to define the message sets for iGame, you can have a GAM-like message approach, and that is from the ETSI standard. It's a broadcasted message sent out with a frequency of 1 or up to 10 Hertz, and it contains information about the vehicle dynamics, the positions, the speed, and we then have to extend that with platooning data and merging data. And what we currently do at our reference implementation, we use, for instance, a high update frequency to get the safe interactions needed for the pairing and merging and maneuvering. And another solution could be a more denim-like message type in the ETSI standard that are event-based messages. So you need an event to trigger such a message, and then you do some update messages about that event until the event has ended. So we can look at the current message sets and see what is available in those current messages and what is not. We can extend them with the message that we think that is needed, and we can make a proposal for future extensions to these message sets so they can support the complex maneuvering. And we can also define completely new iGame message sets that can deal with the non-standard frequency. And such an approach could also be a bit more practical for the teams participating in the GCDC. So to summarize below, option 1 could be just have an iGame specific message sets with all the available fields needed to support the scenarios, or we can use some kind of mixed solution using current available message sets and extend that with an iGame message. So that are things that we are thinking about at this time. So just to summarize and to conclude, that we have designed the interaction protocols for the scenarios we just presented to you. And these interaction protocols, well, we want to show you the video. It didn't work, so you already could see a real-life implementation of it, and also we did some simulations with it. And from this we have already a basic iGame message definition. And the work on message set is still in progress. We have an early draft version available, and we are really really need your feedback or appreciate feedback on some of the basic ideas we have, so we can use that feedback in the next step we are facing and to design a final message sets. So I think that is the presentation for now. So I'm not sure if we can start the poll already.
Yes. So so the next poll is you can perhaps start it so everyone has the time to read. So the poll is what do you think will be the main drivers that speed up the real-life implementation of cooperative automated driving? And the first option is, of course, you can also take more than one option. So it's events like the Grand Cooperative Driving Challenge or other types of operational field tests. So the second option is actually standardization efforts, for example, on cooperative intelligent transport systems, CITS. The third option is new laws that enables automated driving on the public roads. The fourth option is new enabling applications offering economic advantages. For example, reduced fuel consumptions, congestion reductions, and these kind of things. And the last option is improved road traffic safety, less accidents. So I think we have 57, 63 votes. Yeah, going to 83. So it starts to stabilize. So then, okay, we can stop this and then we can look. So 17% think that events like the GCDC may contribute to the speed up of the real-life implementations. Others, 41, always in the 40, 50 range is standardization efforts, new laws. 55% on new enabling applications offering economic advantage. So the closer we are from the actual user, of course, the closer we are going to speed up the real-life implementation. So this should not discourage you. I think that what you're doing is great, but it's very early compared to the actual reach to the consumers, I guess. Yes. So I would like to encourage anyone to also continue to ask questions in the question pane. But we will start again with another poll, the number 3. So, in your opinion, what are the major outcomes of the events like GCDC? And so, a good source of networking among the involved parties. An incentive for participants and organizers to further push the limits of the available technology. So I don't know why this was truncated. And then providing a good mean of information exchange for the participants and organizer. There you can select only one, but let's see, okay, 60% voted. And we will stop and show the results. And basically, 1/3 thinks that it's a good source of networking. The other third thinks that it's an incentive for participants and organizers to further push the limits of the available technologies, and then also providing a good mean of information exchange, 36%. So more or less the same for everyone. So there was a couple of questions, but perhaps Bastien, you may want to update us about the week that you had in Helmond this week. Can you just summarize what it was and then how did it go so far?
Yeah, I'm very proud to inform you about that. Actually, yesterday we started with the Automotive Week. It's a week which will last for 1 week, and during this week all kind of meetings, exhibitions, demonstrations from various projects, and many of those projects are international projects on cooperative driving, automated driving, and on the combination of the two. And yesterday we started the day with the opening of a very innovative traffic control center, which really also makes the connection towards cooperative mobility, a unique facility. And at the same time we demonstrated cooperative automated truck platooning. So in front of the automotive campus here, there were many people who could see 2 trucks driving an automated mode at short distances. And the third one was that we also really saw what cooperative ITS can do to improve the safety of vulnerable road users. So that was a typical example where cooperative bicyclists and cars and partly automated cars can really improve the safety of pedestrians and bikers. So the week started with many demonstrations, and now for the rest of the week there will be meetings from the different projects. And one thing which is of course also very relevant in this context, it's the ETSI plug test, which is held here at this facility. There are many people from all over the world testing the latest protocols, and I think in this context it's a very interesting element, because that's of course one of the end goals of iGame. We want to, let's say, come up with possible future solutions, future protocols. So good start, and I think many more nice interesting things to come.
Okay, we have a few questions from the audience on the presentation, and the first question, which would be relatively simple, is there any GCDC North American partner in this challenge so far? Can you, or anywhere else actually from the world?
No,
only European.
Mainly it's European. In the previous GCDC there was a partner from Waterloo in Canada, Waterloo University, and also from Ohio in the US. So there was a connection with a few universities, and we hope this time that more universities, but possibly also OEMs or other research institutes or even suppliers are in some way connected to a team that participates. So also to our friends in the US, we really invite you to be part of this. And of course also for Japan holds the same. I think over there, of course, also a lot is happening in cooperative automation. So let's make it a global initiative.
Okay. Another question, and I encourage anyone to pose question on their question pane, is so how will the autopilot decide whether it will base its decisions on the messages or on the LiDAR, or of both? So basically we are talking about data fusion here, and what should be the priority in the case of the scenarios that you're developing?
So, if possible, can you repeat the question again?
Yes, the question is basically, will the vehicles also have sensors, onboard sensors, on which they can take the decisions to merge, or will it only be done via the messages that are sent between the vehicles?
No, the vehicles, they are all equipped with onboard sensors, but the requirement, I mean, the necessary thing to do the final steps of merging is based on the communication. So we cannot accomplish the maneuvering without communication. So it's, but we do have also fully equipped vehicles.
Okay, thank you. there is another question from the same person. Is there a digital car ID in the architecture, and is this used in the message format?
Yes. Definitely. We need really unique identifiers for the vehicles. We need it for the interaction protocol and also for every message that is being broadcasted. It should be coupled with a unique ID. So yes, that's in it. Yeah.
So this will go on top of the, let's say, the efforts to be anonymous in the CAM and the DEN, and so there will be some kind of identification of the vehicles in the platoons.
Yes, definitely.
Okay, more questions. The questions are flowing, so I try to go from one to the other. To what extent can the message set you developed be reused for other scenarios? Have you looked also at the fact that these message sets will be used for other situations?
Well, our main focus, of course, is supporting the scenarios that we have defined and the interaction protocols needed in those scenarios. But we keep an open mindset where we can. So we try to support as much as options as possible. But still we have to also take some boundaries in account that we cannot support all possible complex maneuvering.
So another question is, how much interaction is there with the road infrastructure? Actually, two have asked the question. So
yes, okay, that's a clear question. So we do use, we have the option to use some of the infrastructure, roadside units, for instance, but we mainly focus on roadside units for controlling some situations. So to control a scenario, when should the scenario start, and when we look at the interaction needed, we mainly focus on vehicle-to-vehicle communications. The cars involved should just interact with each other and solve the situation, and not the infrastructure.
Okay. So, so this perhaps answers also another question, is whether you're considering to use LTE or ITS G5.
Sorry, I did not really understand the question.
So the question is, perhaps you have answered, but I want you to confirm, do you use LTE or ITS G5 in the whole product?
Okay, thank you. I did not understand the LTE part, but okay, yeah, we are focusing on ITS G5 for communication, for vehicle-to-vehicle communications.
Very good. Another question is, are the scenarios driven in real traffic or on closed test track?
It's closed.
They will be on closed test tracks, but especially in the second scenario, as you've seen, so the intersection scenario, we have different type of vehicles, so they are not all fully automated. Because we want to address, let's say, the mixed traffic issue.
Another question is, I'm not sure I understand it very well, but how can GCDC reduce the concerns of automation failure based on the assumed scenarios? I don't know if you understand the question.
Can you repeat it once more? Yeah.
How can GCDC reduce the concerns of automation failure based on the assumed scenarios?
I think one point that we can do is we have our scenarios, and it's a simplification of real life. But if we manage to do well in those, well, simplified scenarios, that could be a real good basis to extend to real life, more complex situations.
And although, yeah, I fully agree with that point, at the same time, if you look at the early applications of automated driving, this still might look a bit futuristic for many. But also a key element of the project is the validation process, or the safety validation methodology. So it's also a key element, and we will focus on this part for all those vehicles that join the competition. So it will definitely, we will draw some conclusions from that.
Very good.
And also, just to add to the previous question, if we are using closed roads, if we take, well, just only a point of view related to safety and also on law, we really are mandated to close the road to perform those kind of scenarios.
Good. Another question interesting here, is there any requirement on accuracy and reliability of the positioning information of the vehicles before going ahead with the scenario operations?
Yes, definitely. There are minimum requirements for the onboard sensors that are used, for the GPS to be used by the vehicles. Yeah, there are minimum requirements. Otherwise, the scenarios are not implementable.
So are you using simple GPS receivers, or are you using more than that?
Well, for the benchmark vehicle, that's because we are also in charge of developing a benchmark vehicle. So for that one, we try to use the cheapest available solutions. But for the participants, it's up to them. Because the more that you expense for the sensors, the less effort you need to put into development of, let's say, softwares. So it's up to them if they want to invest more in their sensors or they want to have more sophisticated softwares.
Mm-hmm. So a question on, I think related to an earlier question, is how do the vehicles know their relative position to each other?
Well, it's using their onboard sensors. It's mainly by the onboard sensors. Radars, camera.
So is there a set of sensors that you're requiring, or is that completely free for the different teams?
I think the type of sensor is arbitrary, but the accuracy and resolution, the minimum accuracy is mandated. But whether they want to choose LiDAR or a radar or camera or a combination or how many sensors, it's arbitrary.
Is there other scenarios that you're considering as the challenging scenarios, but will not include in GCDC this time? But was there other challenging scenarios that you were looking at?
Well, there were different scenarios suggested by different partners, and what we did in the end is also make a sort of a combination of many of those, because there were many similarities between the suggested scenarios. Now there are two for the competition. There's a third one for demonstration, but also to create an open invitation. We said during this weekend, 2016, there will be the challenge, but we also invite OEM suppliers, other research institutes, if they want to demonstrate their latest technologies on automated driving. If we have a closed highway, we will do everything in our position to make also additional demonstrations possible. But those will not be part of the challenge itself.
Thank you very much. I think that more or less concludes this list of questions. I hope that I browsed through most of them. Oh yeah, an interesting question that is recurring questions. Do you have any communication or any contacts with Google driverless team?
We hope they are listening now and they definitely want to join, but no, not yet.
Great.
But yesterday we had the first subscription, the first registration of the first team that said, well, officially we will be joining. So if those who want to be second, you're free to join.
And an interesting question following up the question on the sensors is, will you authorize non-instrumented vehicles, meaning no sensors on the vehicle, only relying on the V2V?
No.
No.
No. So all the vehicles should have a set of both sensors and V2V in order to be able to meet the requirements to participate.
Yeah, and perform safely in a scenario when you need the sensors.
Yeah.
Okay. So with this, I would like to thank you very much. I think we went through most of the questions, and it's going to be a very exciting time ahead for iGame and GCDC. Wish you all the best and maximum of teams collaborating and competing at the same time. And I really congratulate you for this very interesting project that we will follow in the next few years. Thank you, and thank you to all the audience.
Yes, thank you all, and please visit our website if you need more information.